All right, welcome everybody. So today we're going to throw together all those time value of money functions that you learned in Excel to put together a professional sort of retirement model or retirement planning model. And this is something similar to the software that a lot of financial planners use when they advise clients. And the goal is in the next 40 minutes or so that you won't ever have to sit down and do one of these things on your financial calculator again. You'll have it modeled in Excel and you'll be ready to roll. Okay, so all of us at some point, we want to retire someday. If I'm sitting here today at time 0, most of us in the room are around 20 years old. This is kind of, we're 20 years old. That's my fake year 0. Okay, that means I can get probably about 45 years of work out of everybody. Okay, here to year 45, where y'all will all be 65. Okay, and then 1 year later, at time 46, and when you're 66 years old, we're going to start retiring. Okay, so we're going to retire. We're going to take out money, we hope. So these are going to be inflows. Out at year 46, 47, etc. Okay, and then somewhere way out here in the future, we'll call it year 70, which puts us all at the age of 90. We are going to end retirement. Read into that whatever you want. Okay, and so our last year of retirement, we are going to take out one more cash flow from our retirement account, and we are going to end retirement. Okay, so this is the sort of thing we want to know is we're going to take all this money out when we retire. Our goal is to figure out what we need to be saving each year today, which is money out of our pocket into the bank, so that we can afford this beautiful retirement that all of you want to take. Okay, this is the structure of the problem. Okay, so again, dream big, whatever you all want to do. Usually my students tend to circle in the $200,000 to $250,000 range per year when you retire. So starting at age 66, you want to take out 200 grand a year. Okay, and that is going to be each and every year. You'll take out one last shot when you retire, and the end. Okay, also in this last year of retirement, we're going to do one more thing, which is we're going to leave behind an estate that can either be money for our ungrateful children or money to name a chair for our favorite professor at Eller, anything great like that. But again, it can be any number you want. And in fact, I would recommend using my numbers to start because you're going to see when the model's built, you can change these to anything you want. So I'm going to start off by assuming that when I end retirement, that I'm going to leave $1 million behind either for my favorite professor or for my ungrateful children. Okay, so this is the structure of the problem. We get the one more wrench in it, just to be fun, is out here at year 20, say, so we're 40 years old, we're going to take out some money and go have a big 40th birthday party for our midlife crisis or take airplane lessons or any sort of this great stuff. So we're going to put aside a budget of $50,000 for us to take out of our savings account for us to solve our midlife crisis with a massive vacation or a boat or some sort of crazy purchase. Remember, since we're spending the money, it's really tempting to put a negative sign on here, but what we care about in Excel modeling are the cash flows between us and the bank. That's it. Doesn't matter what we spend it on, doesn't matter where it comes from. The cash flows from our pocket to the bank are outflows to us, and when those cash flows come from the bank or retirement account back to our pocket, those are positives. So if we take the money out and spend it on a vacation, it's going to be a positive. And so I think we said we're going to take out $50,000 right here at age 40 in year 20. So we'll have an extra withdrawal. If you wanted to model an extra deposit, which I'll have you do in an assignment, it's quite easy. If you're going to put extra money in, doesn't matter where it came from. These are trick words in a question. Wherever it came from, when the money leaves our pocket and goes to the bank, it is an outflow. Okay, so extra deposit is going to be an outflow in the model, and extra withdrawal is a positive here. Okay, so here's our kind of ugly looking timeline. We're going to put money in, put money in, put money in. We're going to turn 40. We're going to take out one big withdrawal so we can have a big party, and then keep putting money in, keep putting money in, keep putting money in. At year 46 or age 66, we're going to start retiring. Money's coming out to our pockets. These are positives, positive, positives. And then an extra kicker, this is our estate at the end, or our inheritance, or whatever we want to call this. Okay, this looks a lot nicer on a whiteboard, so I apologize. But let's go ahead and start building the model. The first thing we need to do is to solve the problem. Okay, and so this is going to be, I'll just call this the problem. We'll model this in just a minute. Okay, and the goal, anytime you have a horrible timeline like this, is to work right to left. Okay, so I'm going to start right out here with these cash flows. So these cash flows from time 46 out to time 70. These are my cash inflows. I've got payments of 200,000, 200,000, 200,000, and I've got this extra lump sum of $1 million out here at year 70. Okay, which is, again, age 90. So that's 25 years of cash flows. You can count on your fingers if you don't trust me. Okay, so I'm going to go here. I've got a future value of $1 million. Okay, and I have payments of 200,000. Again, let's go see where those came from. Okay, payments of 200,000 to $1 million. Remember, we can change these assumptions when the model's done. So these are not set in stone. It's a nice thing about Excel. Okay, and I'm going to find the present value of these things. All right, so I need a couple other pieces of info to calculate the present value. I need to know the number of periods, or the N, or the T. And I need to know a rate. Again, these are assumptions that can change. So this is 25 years out here, so 66 to 90. That's 25 years of retirement. And then the rate, this is going to be an assumption and we can change it. So I'm going to use 5% for now. This is going to make a big difference, right? So if you're invested in really safe assets and you get a lot lower than 5%, you're going to be saving a lot more. If you're invested in risky assets that pay off, which is obviously a gamble, then you're going to save a lot less. And we're going to calculate the present value. Okay, so equals PV. It's going to want a rate. It wants the N, the payment, and the future value. I'm going to close it off after 4. You can put a 0 in for type if you like. It's not required. So when I close this off, I get a negative 3.1 million. So let's point out a couple things here. Okay, the first thing is, remember, if this is the first payment at year 46, the present value function is going to give me a number as of right here at year 45. Okay, so we need to be careful. There's a temptation to accidentally put the present value right here at year 46, and it does make a difference. So this payment starting at 200,000, we get a present value here at year 45 of negative 3.1 million. Well, that's really weird, right? Why is Excel giving us a negative here? The reason is Excel's brain thinks just like your cash flow statements, and Excel's brain is also set up for one-shot problems. To say this another way, one option, if we weren't saving every year, is if I could just will $3.1 million out of the sky, right here at year 45, I could write a check, an outflow, for $3.1 million right here, and my retirement is taken care of. That's not what we're going to do. It's not a one-shot problem, so we're going to have to keep correcting Excel, because that's how its brain is wired. Okay, another way to think about this is the day I retire at year 45, to afford this retirement scheme, I better have $3.1 million in the bank, or I'm in some trouble. Okay, I can't afford that. The upshot with a multi-step problem in Excel with time value money is Excel is going to lie to you and keep trying to switch the sign every time I move a cash flow around. So for the moment, I've boxed up the 200,000, 200,000, 200,000, 200,000, $1 million, and I've said right here at year 45, this is worth $3.1 million. Okay, and not a negative, because this is not a one-shot deal. I'm not writing a check for 3.1 million. So the simple way to say this is once we get our timeline down on paper here, whatever I have signed these cash flows, anywhere I move them on the timeline, I never change them no matter what Excel says. Okay, so if these cash flows are assigned positive, which they almost always will be in a retirement problem, once they're positive, I want you to think like a motivational speaker. They're going to stay positive no matter what Excel does. Okay, so we have the million, 200,000. These are positive cash inflows. Excel is lying to us here. It tells us negative. We know we need to stay positive. Okay, and that is the PV at year 45. All right, the goal is to get this whole timeline back to 0. I've actually killed this entire timeline. Now I have 3.1 sitting out here at year 45, 50,000 sitting out here at year 20. I need to get both of these back to time 0. This is stuff we've been doing since our first day at Eller. So to get back my 3.1 million, that present value becomes a future value. Okay, we're going to link it. Please don't type. Link it. That's coming back for 45 years, the 3.1 million. I'm trying to get it back to today. That rate is going to stay the same. Again, if you wanted to complicate this model in the future, you could use a different rate for investing during those 45 years and a different rate for the years when you're withdrawing it, because most of us want safer returns later on in life. For now, we're going to assume that we just get the market rate forever. So I'm going to link that up as well. We don't retype anything that we can link. And then I want to calculate the present value. Okay, if I just punch this in, Excel is going to give me a negative present value, but I know that, like a motivational speaker, we need to stay positive. So I'm going to go ahead and force that sign to flip by putting this little negative sign in here. You can also multiply it by -1 if you prefer. It doesn't really matter. But I'm going to go ahead and force it to flip from the beginning because I know Excel is going to try to lie to me. Okay, so there's my present value. There's the rate. There's the N. There's no payment here. You can put in a 0 if you want. I prefer to just put a blank space, and Excel reads that as 0. Actually, it's VBA reading that as 0, but we'll talk about that in a month or two. And then the future value is this 3.1 million. And I get a present value of, call it a shade under $350,000, and that is what, that is what this 3.1 million is worth today. So this 3.1 million, if I do a little line back, maybe, is worth, is it 346K? And now that guy's gone. Okay, another way to think about this is if we had a rich grandmother who loved us enough to write us a check for $350,000 today, we don't have to save another dime for retirement. It is completely taken care of. So again, thinking about the power of compounding, throw $350,000 in the bank today at 5% interest and just wait 45 years, that retirement that y'all all wanted of $200,000 a year is completely taken care of. We don't have that. We're going to save every year, at least I am. So we'll eventually need to convert that into payments. Let's go ahead and get this last $50,000 midlife crisis back to today. So again, that future value is $50,000. That N is 20. That's again the years until we take this great vacation or buy something really illogical. That rate is 5%. 5% is already on the page, so I'm going to link it. You can link up here to the one just above, which on my page is B9. It could be different on yours. I'm going to save myself a step and link it back to this very first one. And you guys will see why if you watch this video a couple times. But I'm going to link back to that first one. And I'm trying to calculate the present value. All right, so there's the rate. There's N. Again, there's no payment here. You can put in a 0. I'm just going to put a blank space. There's my future value. I know that Excel is going to try to flip the sign, but it's positive on my timeline, so it's going to stay positive. Okay, and now I've said, if I go back to the timeline, this 50,000 here today is worth, call it 19K. And that's gone. All right, so think about the timeline. I've got 246K today, 19K today. They're both at year 0. So I could add these up. Okay. So that's going to give me about 365K today. All I have to do is convert that into payments. Okay, so let's get my new present value. It's the sum of that times 0 value and that times 0 value. I need a rate. That rate is already up here. I'm going to grab this first one, but it doesn't really matter which one you grab as long as it's not typed in. You'll just create yourself a couple extra steps if you grab one of those 5% further down. Okay, the end. How many years am I saving for? Well, it's 45. That's already up here as well. So I'm going to link. All right, and then what I'm solving for is payment. Okay, so again, that's the present value function is payment. There's my rate. There's my N. There's my PV. Now the interesting thing is if you have been a good boy or girl with your signs, when you hit enter here, you're going to get an outflow. Is that the right sign? Remember, inflows are money that goes from the bank to our pocket. Outflows are money that goes from our pocket to the bank. So this is the right sign. This is money that I've got to pump into my retirement account or into the bank every year at 5% to afford that retirement. So if you have been a good boy or girl with your signs, this very last one should be an outflow. This is money we're depositing into the bank. Okay, so that's a nice check on yourself as you go forward. All right, so let's go ahead and model this. This is great. This works once. It's for these very specific inputs. Let's turn this into a model so that I can change things like how much money I want to retire on, the value of my estate, the interest rate, how long I want to work, because between $20,000 and $21,000 a year saving may not be realistic for a lot of people out there. And so now we can reverse engineer what sort of retirement we're looking at based on what we can afford. So I'm just going to duplicate this tab. And I'll call this one model. That way I don't screw up my work here if something goes off the rails. Okay. I'll delete my notes. And what I'm going to do is I'm going to scan up and down here, and whatever I've typed in, whatever is hard keyed in, I get to keep. Okay, so this million I typed in, I get to keep that. That 200,000 I typed in, I get to keep that. The 25, we're good to go there. Those are the years of my retirement. This initial 5%, I get to keep. My 3.1, that's a calculation, that's got to go. This 3.1, that's a formula, that's got to go. These 45 years, that was typed in, I'm good to go there. 5% should be linked. If it's not linked on yours, go ahead and do it now, or you're about to have some problems. And then this present value calculation of 346 and change, 347, is a formula as well. My 50,000 and my 20 years, this is my midlife crisis vacation. Those were typed in. The interest rate and present value calculation should be formulas. And then down here at the end, the PV is a formula, the 5% is a formula, the 45 is a formula. This payment of 20,000, that is my answer. So I got to hang on to that as well. And now I'm ready to roll. So what's going to happen here is all this other stuff that I've not highlighted, this has got to go. Just like the timeline, I'm going to start here from the end. And I am going to roll this thing up bottom to top. And we're going to do this by playing a bit of Jenga. Okay, so I'm going to try to replace each cell and delete it. And if my tower falls down, I'm going to use this handy back key and try again. Okay, so the way I'm going to do this, this is, my math nerds out there, this is just algebraic substitution. This is not, there's nothing magical about this. I'm going to light up the formula, and I'm going to read left to right. B18, that's this R of 5%. Do I get to keep B18? I do not, because I didn't highlight it as one of my keeper cells. So all I'm going to do is I'm going to go into B18, go into the cell itself, look at the formula. Everything to the right of the equal sign, I'm going to copy. And I'm going to replace that reference here in my answer. I'm going to replace that reference to B18 with whatever formula was in B18. So I've just copied. It's Control-C, by the way, or you can use your keyboard. I'm going to go back in here and I'm going to replace that reference to B18 with the formula that was in B18. So that's B4. I'm going to hit enter. Make sure my number doesn't change. So that's first check. Make sure that the number doesn't change. If it does, you've screwed something up. And then I'm going to try to delete that row. All right, I'm good to go. If something changed here, then I've got a problem. Okay, so let me, again, fire up my formula. I'm going to look left to right. B4, hey, I get to keep that one. Making progress. B18, this N of 40, I don't get to keep that cell. So I'm going to go into B18. I'm going to grab everything to the right of the equal sign. I'm going to copy it. Again, Control-C, I like keyboard shortcuts. I'm going to go back in to my answer. In that reference to B18, I'm going to replace with whatever was inside the cell B18, the formula, which is that B8 reference. I'm going to hit enter. Whoops, maybe. Again, when it goes off the rails, just use that back key. I'm going to hit enter. And I'm going to try to delete this cell, cross my fingers, and we're still good to go. So again, it's like playing Jenga. I'm going to keep pulling blocks out and pray that the tower doesn't fall down. All right, B4, I'm good. B8, which is that reference, I'm good to go. Do I get to keep B17? I do not. So I'm going to go into B17. Same rule, guys. I'm going to grab everything to the right of the equal sign, copy it, and I'm going to replace B17 with the formula that was in B17. Everything to the right of the equal sign. So Control-V, the whole thing goes in there. B15 plus B8. And then I'm going to cross my fingers, play Jenga, and I'm good to go. Nothing changes. The answer's still there, and I've got rid of some cells. All right, let's keep going. Excuse me. B4, I'm good. B8, I'm good. B15, I'm not good, so I'm going to go into B15 and replace this B15, that reference, with whatever stuff is in the cell to the right of the equal sign. So I'm going to go into B15. Oh man, it's a horrible formula. That's okay. The same rule all the way through. It's the exact same algorithm. Everything to the right of the equal sign. Copy. And then B15 is going to get replaced with everything to the right of that equal sign. So there we go. Hit enter. Try to delete. And I'm still good. Again, if yours goes to hashtag value or the number changes or something, just go backwards and keep rolling with something else and you should eventually get there. All right, B4 I'm good. B8 I'm good. B14 I'm not good. Okay, so again, same rule. I'm going to go into B14. I'm going to replace that reference with whatever's in there. It's that reference to B4 that we know and love. So B14 replaced by whatever was inside B14, which is that reference. Delete. And we'll keep rolling. B4 I'm good. B8 I'm good. B4 I'm good. B13 I'm good. B12, I feel like I'm playing bingo here. B12 I'm good. This reference to B10, not good. That's got to go. Same rule. I'm going to go into the cell B10 and look at the formula. Everything in here to the right of the equal sign, I'm going to copy. Replace B10 with whatever was in B10. Hit enter to make sure the number doesn't change, and then try to delete B10. Okay, we are almost home. All right, B4 I'm good. B8 I'm good. B4, 11, 10. B9 I'm not good. That's my rate cell here. By this point, we know it's pointing to B4, so if you're starting to get the hang of this, you can just change it manually if you want. For the sake of everybody, I'm going to, again, go in and look. It's equals B4. Copy everything to the right of the equals sign. And replace B9 with whatever was in B9. And try to delete it. Again, you're going to spot shortcuts as you do this a lot. But your first couple times through, it's probably not a good idea to skip steps, because if it collapses on you, you're not really sure where you went awry. All right, B4 I'm good. B8 I'm good. I'm good with this formula. B4, B8 again. This reference to B7, which is this 3.1, that's got to go. I'm going to go into the cell, grab B5, copy, and delete, and we are almost home. B4, B6, B4, B8, B7, B4, B6. We're golden everywhere except for that last reference to 3.1 million, this B5, at least on mine. So same rule, everybody. I'm going to go in here. I'm going to grab everything to the right of the equal sign, copy, replace, hit enter to make sure the number doesn't change, and then try to delete, and we are golden. Okay, so let's clean this model up just a little bit. Okay, let's give these things labels, because if I were just to hand this off to a client, they wouldn't know what the heck is going on. So that future value, that was my inheritance or estate. I'll just call it the estate. And that payment of $200,000 was the desired retirement income. Okay, that N of 25, those are my years of retirement. That R of 5%, that was my rate of return. And we'll pretty this up. I'll make that a percentage just so that that's clear to people. Excel's a bit weird. That N of 45, those were years of working or years of savings. That future value of 50,000, we'll call that an early withdrawal. If you want to call it midlife crisis on yours, knock yourselves out. And that is years until early withdrawal. And then this answer down here, these are the required annual deposits. Okay, and again, we'll clean up some of the formatting here. The other change I'm going to make is if I give this to a non-finance person that's not had the benefit of all these amazing cash flow statements that you guys have all had, then they're going to see this negative here, and they're not going to know it's an outflow like y'all know. They're going to see this and say, sweet, I get to save negative $20,000 a year for retirement. That's not what we want them to think. So I'm going to go ahead and flip the sign here. And so now they know they need to deposit between $20,000 and $21,000 a year to hit those retirement goals. All right, so again, once we're done with the model, right, it's just like what you do with a model airplane or a model car, you play with it. Okay, it's a toy to get to tinker with to see what changes with reality. If we think we can beat that 5% and get 6% return on our money, then you can see that the required deposits to hit your goals go down. If we think we can survive on $100,000 a year in retirement instead of $200,000, then those deposits go way down. If we invest in really safe things, we get a low rate of return. You can see that the required deposits go way, way up. So again, the goal, these inputs, I can change any of these inputs up here and see what happens with my deposits. So if you look at this and you say, geez, there's no way I'm saving $20,000 a year. Maybe $10,000 is more my number. You can play around with these and see what sort of retirement you can afford on that sort of basically your budgeted deposits. There's one more thing I'm going to do, because if you notice, if I just scan, these are all typed in. All the action, all the love in this model is right here. Right, so the problem is, if I give this to somebody who doesn't know what they're doing, the first thing they're going to do is come in and type something over here. And oh man, all of our hard work, everything we just spent, the last half hour on is gone. We do not want that. Okay, so before we give this to somebody we know is going to destroy it, let's kind of keep them from messing with this cell. So I want them to be able to change these cells. So I'm going to highlight the cells I want them to be able to change. I'm going to go down here to Format Cells. I just right-clicked. You can get to this several ways. Format Cells. And then I'm going to go here to Protection on the last tab. I'm going to untick this checkbox for locked. And so these cells are unlocked. And then the last thing I'm going to do is go here to this Review tab at the top, right here. Protect Sheet. And it wants a password right here. I'm just going to put Eller in lowercase. Put whatever you want, just don't forget it. Wants me to re-enter it. Now this thing is locked. I can still change my input cells here. And my model updates. But if I try to change this cell, I get an error message saying that this thing is locked out, you can't change it, and it keeps our user from messing up our model and destroying everything. So I'm going to go ahead and unprotect it before I upload this for everybody. But there we go. We have a professional, essentially, financial planning model that's very similar to what financial planners use when they sit down with clients and tell them how much they need to be saving for retirement. And we knocked it out here in less than 45 minutes. All right, so everybody get this shot. Let me know if you have questions, and we will talk soon. Thank you.